here's the lesson from day 2 of Unit 4. So we started with this warm-up today. Take a moment, pause the video, try the warm-up, and then play to check your answers. So the vertex, so we know adding 5 before squaring means a shift to the left 5. So that means going from 0, 0, I'm now at -5. And then plus 7 means up 7, so positive 7. So -5, 7 is the vertex. The equation of the parabola that has a vertex of 5, -8. So 5, -8 means we write y equals a times parentheses x. Positive 5 means 5 to the right, so -5, the quantity squared. And then -8 means down 8, so subtract 8. So I'm going to substitute in the coordinate point, -35 in for y, and 2 in for x. So 2 minus 5 is -3, squared -8. So when I square -3, I get 9. So I have 9a minus 8. So I'm just going to rewrite that as 9a. And then I'm going to add 8 to both sides, which is -27. Divide by 9, which gives me a is -3. So y equals -3 times the quantity x minus 5 squared minus 8. Okay, so that last equation that we came up with there, that is in, if you remember from last lesson, we call that vertex form. So we're going to talk about, that's what we're going to talk about today, is vertex form and standard form for quadratics. So we know that that is vertex form, where the vertex is HK. So if I want to take vertex form and rearrange it to put it in standard form looks like the following. Okay, and if you look at standard form, it actually, you already know standard form, you maybe just didn't know that's what it was called, but standard form is the form that a parabola would be in when we are using the quadratic formula to solve the quadratic for x. It needs to be in standard form, so the ax squared plus bx plus c equals y. So if you're comparing the two forms, you'll notice that there's a in both, and that is intentional. We purposely have the same letter because that value will always be the same. So the leading coefficient will always be the same as the value in front of the parentheses that are squared. And if you think about that, that should make sense because that is the value, we talked about this yesterday, that is the value that causes the vertical stretch, the vertical compression, or the change in orientation to happen. So that is really the value that causes transformations to occur. Okay, so that should be the same whether we're looking at standard form or vertex form. So what we're going to do today is we're going to be going from vertex form to standard form. So if you think about it, how might I go about getting this to look like this? Well, I would have to square the binomial. Okay, I would follow order of operations. I'd square the binomial. I'd multiply that by a, and then I would add on the k. And once I've done that, once I've followed order of operations, the equation will then be in standard form. So that's what we're going to do. So let's try that on this one. So the first thing I'm going to do is, following order of operations, I'm going to square the binomial. And when I square that binomial, I'm going to be careful to correctly square it. So we know x minus 5 times x minus 5 gives us x squared minus 10x plus 25. Think about first outer, inner, last, or make a generic rectangle. And then I have minus 8 on the end. So I'm going to next distribute that -3. And lastly, I'm going to combine like terms. And now I have my equation in standard form. Okay. So we'll try another one. Same approach. I'm going to square the binomial first correctly. Okay. And then I'm going to distribute that 1/2. Okay, and lastly, I'm going to combine like terms. And now I have the equation in standard form. Okay. So this time we are given a point that's on the graph, and we are given the translations or the shifts, and we're supposed to write the equation of the quadratic, and we're supposed to have it in standard form. So if you think about it, this is just like what we did in class yesterday, in yesterday's lesson. And if you think about it, I can't start with standard form. Okay, I wouldn't try and substitute into standard form because all I know is x and y. Okay, and I can't substitute in for x and y. I still have 3 variables, a, b, and c. So that would get me nowhere. But what I do know is I know the vertex because it talks about the translations, and I know a point. So rather than starting with standard, I'm going to start with vertex form. And then after I have vertex form, then I will get it into standard form. Okay, and if you think about that, we did something similar to that in Unit 1 with linear equations. When we were asked a question like, find the equation of the line in standard form given these 2 points, we didn't start with standard form. We started with either point slope or slope intercept form. We found the equation in that form, and then we transferred it over to standard form. We're going to do the same thing with parabolas. We're going to find the equation in vertex form, and then we'll change it over to standard form. So I keep the a. Right 2 means x minus 2, the quantity squared, and then up 6 is plus 6, substituting in the coordinate point for x and for y. So I simplified -8 the quantity squared to give me 64a. Subtract 6 and divide both sides by 64. So a is equal to -1/2. So my equation in vertex form is that, but I'm supposed to then put it in standard form. So I'm going to square the binomial. And distribute the -1/2. And lastly, combine like terms. And there we go. We have the equation of the parabola in standard form. Okay. Next, so over the weekend you looked at simplifying radicals, just the most basic ones for practice. Today we're going to look at some that are a little more complicated with the fractions and with the radical in the denominator. Most of you were probably taught this in Algebra 1, so it's mostly a review. So when I'm simplifying something like this one, the first thing I'll do is rewrite it as the square root of 1 divided by the square root of 4. The square root of 1 is 1, and the square root of 4 is 2. So 1/2 is the square root of 1/4. Now this one here, the problem with it, the reason it's considered not simplified is you can't leave square roots in the denominator of a fraction. So what we need to do to get rid of that square root of 3 is what we call rationalize the denominator, which means we're going to multiply this fraction by √3 over √3. Now, normally, you know that you can't just start multiplying problems by something, because then you're changing the problem, and you can't change a problem, you can't change the value. But if you think about this, I have not really changed the problem or changed the value, because the square root of 3 divided by the square root of 3, that equals 1. And I can multiply anything by 1 anytime I want. So it's okay, I haven't changed the problem, so we're good to go here. So 4 times the square root of 3 is my numerator, and root 3 times root 3, which is 3. Anytime you have square root of something times itself, it's just the number underneath the radical without the radical. So that's how I got the 3. Next, you're going to take a look at the 4 and the 3 and make sure they don't simplify. 4/3 doesn't. So this is my final answer. Had this been like 4/6, then I would have divided both by 2. But I don't need to simplify 4/3. Next one. So I'm going to first rewrite this as root 5 over root 18. Next, I can either rationalize the denominator first, and root 18 times root 5 is root 90, and root 18 times root 18 is 18, and then simplify. Root 90 is what, 9 times 10, so 3 root 10, and then 3/18 simplifies to 1/6, so I get root 10 over 6. Now, I didn't necessarily have to rationalize first and then simplify second. I could have simplified first. So if I had started with root 5 over root 18, and instead of rationalizing, multiplying by root 18 over root 18, I could have simplified the root 18. So root 18 is root 9 times root 2, which is 3 root 2. And then I could have rationalized by getting rid of that root 2. So multiply by root 2 over root 2. And root 5 times root 2 is root 10. Root 2 times root 2 is 2, and 2 times 3 is 6. So either way, I'm getting the square root of 10 over 6. Okay. That's it for notes for today. So your homework tonight is page 3 in the Unit 4 packet, and also pages 2 and 3 of that simple radical packet, that thinner packet that you got and you did the first part of over the weekend. Now I'd like you to do pages 2 and 3 in that packet. That's your homework for tomorrow.